Welcome back to the equations unit. Today we're going to be finishing up the equations units by talking about practical problems with equations. So let's go ahead and take a look at example A. So here we are at example A, and it says Aiden bought 17 lollipops before math class, which is 12 more than the number of lollipops Justin brought. How many lollipops did Justin buy? So the first thing we need to do is go through our equation or our word problem here and define things that are important so that we can make ourselves an equation. So it says Aiden bought 17 lollipops. That's important to know how many lollipops Aiden has, which is 12 more than the number of lollipops that Justin brought. How many lollipops did Justin buy? So that's the important information. It looks like since we're going through a word problem here, we're going to need to translate. We're going to need to remember those things from Unit 4. So if we haven't remembered those things from Unit 4, we can go back and watch that video on translating. However, let's push forward assuming that we do. Now, when setting up an equation out of a word problem, it's important to figure out which each side of our equation is going to be. So we need to set up our equation so that we know that one thing is going to be equal to the other thing. Remember, we want to keep that thing balanced. So we have two things in this problem. One is Aiden and one is Justin. Since we know what Aiden brought, we know his total, that's going to be this thing that we're going to be equaling. So Aiden's total is going to be one side of our equation, and since we know what that total is, it's 17 lollipops, so we're going to put that right in the box, so we know that Aiden's total is 17. So the other side of our equation, the part that we're going to be talking about, is Justin. So Justin owns this entire side of the equation. We're not really sure what Justin has, but we know he's going to be on one side of the equation, and Aiden's total is going to be on the other. So now let's look more deeply at what we know about Justin. We don't know how many lollipops Justin has. So since we don't know what that is, we're going to call that X. So Justin has X lollipops. But we know something more than just X, because it's not Justin has as many as Aiden. It says that Aiden has 12 more than. So let's take Justin's total, and we're going to add 12 to that. And when we take Justin's total plus 12, that's going to give us Aiden's total of 17. So now notice I've set up an equation. On one side of my equation, I have Justin. I don't know how many lollipops he has, but I know when I add 12 to it, I can get the Aiden's total. And since I know Aiden's total is 17, I've got an equation I can solve. So I'm going to draw my wall down for my equal sign. I've got to get rid of my constant because I've got a one-step equation here. I've only got a constant to get rid of. I've got a positive 12, so the opposite of positive 12 is negative 12 or minus 12. They mean the same thing. So I'm going to subtract 12 on both sides of my equation. Positive 12 and negative 12 are going to cancel each other out, which is going to leave me with just X on one side of my equation, and then 17 minus 12 is 5. Now, this is a word problem, so I need a word answer. I can't just leave 5 as my answer. So we need to know whether we're talking about flamingos or money or temperature. People need to know what we're talking about. So in this case, we're talking about lollipops. So our answer is going to be 5 lollipops. Make sure that you write that in your answer. If you don't write down a word answer to your word problem, you're not going to get the answer correct. Let's take a look now at example B. Now, example B says, at his birthday party, Joey ate twice as many cupcakes as Mary. Together, they ate 42 cupcakes. How many cupcakes did Mary eat, and how many cupcakes did Joey eat? So again, we've got a word problem. We got to go through and find the important information in to begin with. So Joey ate twice as many, so that's important information. Together, they ate 42, important information. Then we don't know how many Mary ate, and we don't know how many Joey ate. So now we need to make our word problem an equation. And remember, when we're going to do that, we need to figure out what both sides of the equation are going to be. So on one side of the equation, we're going to have the total number of cupcakes because we know that for a fact. So we know on one side, the total number of cupcakes is 42. So that's going to be one side of our equation, total cupcakes, 42. On the other side of the equation, it's a little bit different this time. We don't have just one thing because our question asks us two different answers. It asks us how many cupcakes Mary ate and how many cupcakes Joey ate. So we're going to need to have one for how much Mary ate and one for how much Joey ate. But we know we're going to add those together, and when we add them together, we're going to get our 42 cupcakes. So we don't know how many Mary ate. That's going to be X. Now we know Joey ate twice as many. So when I'm going to show twice as many as something, that means times 2. But again, I don't know what Mary ate, so I'm going to have to write 2x. So now I've got an equation, x plus 2x is equal to 42. So that would show me that Mary's cupcakes plus twice as many as she ate would give me Joey's cupcakes, and altogether that's going to be 42. So now I need to go ahead and solve my equation by drawing my wall down for my equal sign to begin. Then it looks like I have some like terms to combine, so I have to combine my x and my 2x. So x plus 2x is going to give me 3x. Bring down my 42 because I didn't do anything with that. Now I've got a one-step equation. I need to divide both sides by 3 because the inverse operation of multiplication is division. So 3 divided by 3 is going to be 1, or 1x, and 42 divided by 3 is 14. Now again, I've got a word problem, so I need to come up with a word answer. However, it's not as simple this time because I need to figure out how many cupcakes Mary ate and how many cupcakes Joey ate. I'm going to have two word answers. I'm going to have how many Joey ate and how many Mary ate. And since I have x equals 14, and looking at how I set up my equation, I said that Mary was x. So I know that Mary's cupcakes is going to be 14 cupcakes. But that doesn't tell me how many cupcakes Joey ate. So what I need to do is take what Joey had, the 2x, and figure out how many cupcakes that's going to be. So since I know now that x is 14, I can take the 2 times the 14 cupcakes that I figured out. And when I do that, I get 28. So that's how many cupcakes Joey ate. So Joey ate 28 cupcakes. So remember, I didn't finish the problem by just finding x. I had to solve the problem by actually answering the question that they asked. It's very important that you read the question that the problem is asking you and answer it. If you were just to write x equals 14 at the end of this problem, not only did you not even answer the problem that they asked you, you would get the answer wrong even though you did most of the math correct. Now let's take a look at example C. Here in example C, it says Jessica has $452 in her bank account. She deposits $14 per day. In how many days will she have $942 in her bank account? So again, I've got to set up an equation. I've got to have two sides of my equation. I have to figure out what I'm balancing. So let's pull important information out of the problem first. So we know that Jessica has a total of $452 in her bank account. So that's important information. She's depositing $14 per day. Important information. And how many days will it take her to earn $942 in her account? So right now we have three pieces of information, which is very good for us. We need to figure out what goes on each side of our equation. So on one side of our equation, we're going to have the total amount of money that she's looking for. So the total money is going to be on one side, and looking at this problem, the total money is going to be $942. So on the other side of our equation, it's going to be Jessica and all the things that are pertaining to what she's doing with her bank account to reach that total money of $942. Well, the good news is we know that she already has $452 in the bank. Then she's going to be adding to it because we see the word deposits. Anytime that we see the word deposit, we know that means to add. So she's going to be adding money to her bank account, and she's going to be adding $14 per day. So I can't just write 14 because she's not stopping at one day. But I don't know how many days that she's going. So rather than writing 14 plus 14 plus 14 plus 14, I'm going to write 14 times the total number of days. Or in this case, since I don't know the total number of days, that's going to be 14x. So now I've got myself a two-step equation that I know how to solve. It's all worked out. I've got Jessica on one side, total money on the other. So I'm going to draw my wall down from my equal sign. The first thing I need to do when solving a two-step equation is get rid of my constant. So my constant in this case is the 452. So I'm going to subtract 452 from both sides. Positive 452 and negative 452 are going to cancel each other out, leaving me with just 14x on one side of my equation. 942 minus 452 is $490. So now I'm down to a one-step equation. I need to get rid of that 14. The opposite of multiplying is going to be dividing, so I'm going to divide both sides by 14. 14 divided by 14 is 1, or 1x, and 490 divided by 14 is going to give me 35. So again, I've got a word problem, so I need to have a word answer. Now, there's a lot of money in this problem, so you might be tempted to just put a dollar sign on it and say, yeah, the whole problem was about money, so I threw a dollar sign on there, and now I'm good to go. However, that's not what the problem is asking us for. The problem is asking us for how many days will it take for her to get that $942. So since I'm asking for days, my answer is 35 days. So don't be tricked just because the problem has a lot of information about money in it. That's not what the problem is asking for. The problem is asking us for how many days. So my answer is 35 days. Now let's take a look at example D. So here in example D, it says Jorge's age is 5 years less than 1/2 of Emily's age. Jorge is 11 years old. How old is Emily? So notice our boxes are gone because it's unlikely that anytime we get to one of these questions that there'll be boxes drawn on it for us. So we can put in boxes if we'd like, but usually we're going to get a problem that looks like this. But that doesn't change the way that we're going to solve the problem. So the first thing we're going to do is pull out our important information. So Jorge's age is 5 years less than 1/2 of Emily's age. That's important information. And Jorge is 11 years old. That's important information. Now, I see that word is in front of the 11 years old. So that's important information in the fact that anytime I see the word is, I know that means equals. So if I see is and I'm making an equation, I know that I can write that as equals whatever. So now I'm going to have two sides of my equation. So in this case, I need to figure out what they are. I don't have those pretty boxes for me, but I'm going to be talking about two people. So one person's going to be on one side of the equation, the other person is going to be on the other. So we're going to be talking about Jorge on one side of the equation, and I'm going to put him on the right because we know what his age is, and I'm going to put Emily on the left. It doesn't matter. You could switch them. It's your equation. You could set it up however you'd like, as long as Emily was on one side and Jorge was on the other. Now, we know how old Jorge is. He's 11 years old. That's what the problem told us. So on one side of our equation, we're going to have 11. On the other side of the equation, they gave us a nice little translating expression there, 5 years less than 1/2. So we need to make sure that we take that information and turn it into the things that we know how to use. So less than is going to take that 5 and push it to the back of our problem, just like we learned when we were talking about translating. So I know less than means minus, and I know that less than means minus 5 goes to the back. Then it says 1/2 of Emily's age. So I don't know what Emily's age is, so that's going to be x. And how do I write 1/2 of that? I can write it one of two ways. I could write 1/2 times x, or I could write x divided by 2. It means the same thing. Both of them are dividing by 2. So I'm going to be now solving my two-step equation that I've just created. So the first step in solving a two-step equation is to draw a wall down from my equal sign. Then I've got to get rid of my constant. My constant in this case is -5. So the inverse operation of -5 is +5 or adding 5. So I'm going to add 5 to both sides. +5 and -5 are going to cancel. Then I'm going to get 1/2 x is equal to 16. Now the next part of my equation, I have to get rid of my coefficient. So my coefficient in this case is a fraction. So I have to do the inverse of the fraction or a reciprocal. So the reciprocal of 1/2 is going to be 2 over 1. And I'm going to do that on both sides of my equation because I want to make sure that it remains balanced. So 2 over 1 times 1 over 2, all of these are going to cancel down to 1 or 1x. And then 16 times 2 over 1 or 16 over 1 times 2 over 1 is going to be 32 over 1 or just x equals 32. Now, again, I've got a word problem, so I need a word answer. And since we're talking about age here, we're going to be talking about years. So my answer is 32 years. Now let's move on to the next two examples. So here in example E and G, we're going to be just writing our equations. We don't need to solve these. It says write an equation that you could use to solve this problem, but it doesn't tell us we actually have to solve the problem. So that's nice for us. So if we get a question like that, we need to make sure that, again, we're reading very carefully what the question is asking us. Otherwise, we could end up doing a whole lot of work that we don't need to. So Emma has 42 goldfish. Again, I'm going to be pulling out our important information. So 42 goldfish. She has 2 more than 4 times the number of goldfish her cousin has. How many goldfish does her cousin have? So again, I need to figure out what my two sides of my equation are going to be. In this case, it's going to be how many goldfish Emma has versus how many goldfish her cousin has. So on one side of my equation, I'm going to put Emma's 42 goldfish. And again, I'm going to put that on the right. It doesn't mean that I have to always put it on the right, but it's just easier for me for the one number that I know I'm going to be solving for to be on the right side of my equation. So Emma has 42 goldfish. Now I need to figure out what this phrase 2 more than 4 times the number. Now again, this is an expression that I've translated just like I've done back in Unit 4. So again, I've got my 2 more than. That more than is very important because it knows that it's going to take my 2 and push it to the back of my expression. 4 times a number, 4 times x, because I don't know what that number is going to be. So 4x, and then more than, I know that's adding, and in this case it's 2. So 4x plus 2 equals 42. Now, the problem just asked me to write an equation. I don't have to solve, so I'm done. My answer is 4x plus 2 equals 42. That's my answer. I don't have to go any further. So it's very important that I read the problem so I don't do extra work. The second example there says 6 less than 1/3 of a number is -9. What is that number? So now we've gotten rid of all of the mumbo jumbo about people buying cupcakes and having goldfish and bringing lollipops to class, and we're just talking about straight numbers. So this should be much easier for us. So let's go ahead and pull some information. 6 less than 1/3 a number is very important. Then I see that key word there, that is, lets me know that I'm going to be having an equal sign there. And my last bit of information is going to be is -9. So those are all important pieces of information, and that is throws an equal sign right where I need to know whether it is. So is -9, so I know my equation is going to equal -9. That leaves me with just one part of the expression to figure out. 6 less than 1/3 of a number. So again, I see that less than is very important because it's going to take that 6 and throw it to the back of my expression. So I know whatever we're going to be talking about, we're going to be subtracting 6. 1/3 of a number, so I can just write that out as I see it. 1/3, I don't know that number, so that number is going to be x. So my answer is going to be 1/3 x minus 6. And again, it doesn't tell me I need to solve this equation. It just asks me to write it down. So I've gotten to my final answer. Now let's have you do some practice on your own. So here are some practice. It gives you 4 different examples, and you need to match the equation to this scenario. Now, there are 6 matches to your 4 problems, so you're going to have a couple left over. I want you to do the best that you can with this. So you're going to pause the video now, do the best that you can, then press play again to see if you are right. How did you do? Were you able to come up with all the answers that I came up with? Now, I know the last one there says more than, so that 2 should be behind that 5x. However, we do have that fancy property that allows us to change the order, the commutative property. So in this case, that would give us the same answer, but it would not be an equation that matches this expression. So be very careful. Although that equation will get you the right answer, if you're just looking for a dead-on match, that will not be correct. Now, this brings us to the end of this video, so if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.